So this is G484 homework booklet question 24. It starts off with defining the gravitational field strength, straightforwardly force per unit mass. It might help you to think about W equals mg there. So G would be W the force divided by m, but it's a pretty straightforward definition. No real excuse for getting that wrong. Part B is interesting because it's really a data processing question. It would come very much in line with the stuff you do often in the qualitative tasks. So the table shows information that was known to physicists at the time of Isaac Newton. That's an interesting statement in itself. Nobody would have used the word physicist at the time of Isaac Newton. About the positions about the distances from the centre of the Earth, the couple position and the gravitational field strength. It asks you to use the information provided in the table to state a relationship between the gravitational field strength and distance and to verify that relationship. Badly written question because the relationship doesn't come from information in the table. It's not realistic to work out that. The relationship would come from the fact that you know that G equals gm upon r squared. As G and M are both constants, the relationship is that G is proportional to 1 upon r squared. Now if G is proportional to 1 upon r squared, I could write that as G equals some constant times 1 upon r squared, which makes g r squared constant. So from G, the relationship is that G is proportional to 1 upon r squared. We've got an inverse square relationship, and then the test we can use is that g r squared is constant. So if we do that for the Earth, g of the Earth times radius of the Earth's surface squared, and we get that value. And if we do it out at the position of the moon's orbit, remember this is still due to the Earth, the field strength due to the Earth, we get that value, and they're close enough to suggest that that relationship does hold. We move on. Show the mass of the Earth. Standard question this. You've got to remember this equation that we've got for field strength is gm upon r squared. We can use that to weigh the object. If I can work out G at a certain radius, we can do that, and very often we can do that by measuring periods and radiuses. Rearrange that then, gr squared upon g, or we could of course just throw the numbers in, 9.81, 6.67 times 10 to the minus 11, and m's what we're trying to get, radius of 6.4 times 10 to the 6 squared, and we very quickly can rearrange that and get to a mass of 6.02 times 10 to the 24. Determine the mean density, therefore, of the Earth. Nice easy bit of synoptic work in. Density is mass over volume, so V is 4/3 pi r cubed. Work out the volume, and rho is m upon v, and we get a density of 5,500 kilograms per cubic meter. 1 point just going back, the radius of the Earth that you needed in that question, obviously you had to look back to the table at the beginning of part B. Within part B, any information given in part B you might have to use anywhere within part B, so that's entirely reasonable. And that brings us to the end of the last question from the G484 homework booklet. Huzzah!